Hello and welcome. We are going to discuss reflections over the X and the Y axes, and we're going to talk about graphing images or graphing points after we complete a reflection. So here in this picture, we can see that we've got this triangle. We are reflecting it. In this case, we have to look at where we're reflecting it. So in this case, we're reflecting it over this X axis. Okay, and what a reflection is it's basically a flip. It's you're taking that point or you're taking that shape and you're flipping it over some line to create a mirror image. Okay. Um, when when a point is reflected over the x-axis, the y coordinate is going to change its sign. Okay. And then when the point is reflected over the y-axis, that's where the x coordinate is going to change its sign. So we're going to look at a couple of examples of points, and then we're going to move into shapes and what those reflections are going to look like depending on the line of reflection that we're using. So with this question, it says we need to graph the image of S, which is at 3, 4, after a reflection over the y-axis. So when we look at this, the most important information we have is this pre-image, the starting point that we have. And then we're talking about a reflection over the y-axis. And so here we can see the y-axis is highlighted in green. And that's what you want to find first is where's my line of reflection? Okay. So we'll call this our line of reflection. And then we also have to remember that anytime we have an ordered pair, it is written as X and then Y. So this ordered pair of S is written as 3 and then 4. We're going over 3 places and then we're going up 4, and that's where we get this point of S. Now, when we talk about a reflection, we have our points, we have our point, then we have our line of reflection. We want to see if our line of reflection is right here at the y-axis, how many places away from the y-axis is point S? We'd say, okay, it's 1, 2, 3 places in the positive direction. So reflection would be, we need to find the mirror image of that point, and we have to go over the line of reflection. So we would go the other way and we'd say, okay, 1, 2, 3 right here. And this would be our S, our image after that reflection. And I'm going to kind of take this all away so we can really kind of see, and we can see that it is equal distance away from that line of reflection. Okay, so the image that we would get would be S would be at -3, 4. And again, this is where we would say that because the line of reflection is the y-axis, our X coordinate is going to change its sign. It's going to go from a +3 over to a -3. All right, let's move on to another one. We're going to look at another point here, but this time we're graphing the image of P, which is at -10, 5, and we're looking at a reflection over the x-axis. So here we've got our ordered pair, and then we're reflecting it over the x-axis. So now instead of having that line of reflection as a vertical line, we're going to have a line of reflection as a horizontal line of reflection. And then what we want to do is we want to see, okay, so since this is our line of reflection, how far away is P from that line of reflection? And we'd say, okay, 1, 2, 3, 4, 5 places. We're going 5 places up. We need to find the mirror image. So since we're going 5 places above that line of reflection, that mirror image is going to be exactly the opposite, but below that line of reflection. So now we're going to go down 1, 2, 3, 4, 5 places, and this would be the image of P. Okay. And that would be at -10, 5. So again, our starting point here was at P at -10 and then 5. And then our image was at -10 and now -5. So see how we have the line of, we're reflecting this over the x-axis. So since it's the x-axis, it's going to be opposite. Our y-coordinate is going to be the one that changes. So in this case, -10 stays the same for both. And then our y-coordinate went from a +5 to now being a -5 with the image. So what happens when we are not just looking at a point, but now we're looking at an entire shape, okay? So we've got this image of triangle DEF, and we're talking about a reflection over the x-axis, okay? Which means, again, our y-coordinates will be the ones that are going to change their sign. But before, when we were dealing with just a point, we would only reflect the one point. Here, what we're going to do is we're going to need to take each one of these points of this triangle, and we're going to need to reflect it over the x-axis, which is our line of reflection. Okay, this is kind of our mirror that we're looking into, and this is where we're going to see that image on the other side. So first, we're gonna start with the points all by themselves. Okay, we're not going to try to do the whole triangle all together, but we're going to take this first point. Let's start with D, and we're going to see, okay, how many places is D away from that line of reflection? And we'd say, okay, 1, 2, 3, 4, 5, 6, 7 places. We're going 7 places down, and so our reflection of it is going to be exactly the opposite of 7 places up. So 1, 2, 3, 4, 5, 6, 7. And this is going to be our D, our image of the point D. And I'm going to erase all this just so that it's not in the way as we're reflecting the rest of the points as well. So then once we have found the image of that point D, we can move on to the next point, which we'll look at point E. So point E, we're going to do the same thing. We're going to say, okay, from this line of reflection, we are 1, 2, 3, 4, 5, 6, 7 places down as well. And so we're going to go the opposite, and we're going to go exactly 7 places up for our mirror image. So this would be E. And again, I'm going to go ahead and erase all of this so we can continue reflecting these points. So now the last point that we have is point F. And so this point is much closer. It is our line of reflections here. We're going 1, 2, and then 3 places down. So we're going to do the same thing here. 1, 2, 3 places up, and that would be F. Once we have all of our points reflected across our line of reflection, we can go through and we can connect those points. And I know my triangle looks a little bit differently, but again, this is a reflection across the x-axis. So it doesn't change the size and the shape of from the pre-image to the image. It might change the orientation, which is the way that the shape is pointing or the way that the shape looks or how it's turned. It could change that orientation of the shape. And in this case, it does look like it is flipped upside down. So now we have this short side here of DE. Now we have it on the top over here instead of the bottom, okay? So it could look slightly different, but again, if we double check, we could say this is 1, 2, 3, 4, 5 units, 1, 2, 3, 4, 5, same size. It's gonna keep that same size, that same shape that we're talking about, that triangle. All right, let's take a look at another one here. Again, we have a shape. Now we're looking at this square of QRST after reflection over the y-axis. So in this case, we have our line of reflection is our y-axis. And we want to take each one of these points of QRST, and we're going to move them. We're going to reflect them over this y-axis. So we're going to start with this point Q, and we want to see how far away is this point Q from that line of reflection. So 1, 2, 3, 4, 5, 6, 7 places away. And so we're going to go exactly 7 places in the other direction. 1, 2, 3, 4, 5, 6, and then 7 this way. And this is going to be Q prime. We're going to do that with each one of our points. And I'll put that line of reflection back. We've got the line of reflection at the y-axis. So now we're going to move on. We can move on to point, we'll just move on to point T. At this point, T is going to be, it looks like it's lined up with Q, so it's probably going to be 7 places as well. 1, 2, 3, 4, 5, 6, 7 places. So we're going to go exactly 7 places the other direction as well. 1, 2, 3, 4, 5, 6, and then 7. And this is T. All right, and then we can move on to, we'll move on to R here. We want to see how many places away from that line of reflection R is. So 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So then when we go to graph, we're going to go exactly 9 places in the other direction. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And this is going to be R. We'll get rid of all this so we can continue. We've got one more point left to do, which is point S. So we will get point S moved as well. Point S from the line of reflection is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 as well. And so we're going to go exactly 9 places the other direction across the line of reflection. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And I'm going to erase all this so we can check our graph. I'll put this back here. And so once we've plotted all of those points, now we can see that we have this square. Looks identical to the pre-image that we started with. Okay. The only difference is now it's reflected. And again, with this y-axis, that means the x coordinates are going to change. So that's a really great way to check your answer as well. So if I just looked at, let's say I look at Q, which is at 7, and then 3. And then I look at Q prime, which is at -7 and 3. I can see that I started with a +7. My x coordinate's going to change. So I started with a +7. And then once I reflected this across that y-axis, that's where my x coordinate changed to a -7. So that's a great way to check your answer as well. Kind of go through, look at the coordinates and see, if I'm going across that y-axis, did all of my x coordinates change, but are my y coordinates still the same? All right, and then we're going to look at one more example here. Here we have this rectangle STUV after reflection over the x-axis. So now we're looking at this x-axis as our line of reflection. And so with this x-axis, we need to look at each one of these points separately, and we need to decide how far away are they from this line of reflection, and how do I reflect it across this line of reflection. So I'll start with the point S because it's kind of the furthest away. And remember, your x-axis, if you're reflecting it over the x-axis, that means the y coordinate is going to be the one that changes its sign. So if it's a positive, it's going to go to negative, and if it's a negative, it's going to go to a positive. So I'm going to start with S, and I'm looking at the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. And I'm going to say that this is 10 places down. So I'm going to put a -10, which means to reflect this across this x-axis, I'm going to go 10 places in the positive direction. 3, 4, 5, 6, 7, 8, 9, and 10. This would be my S. And I'll erase this so we can keep plotting those points, moving those points, reflecting them. Then I'm going to go to my next point, which is I'm going to go to T here. You see, okay, from the x-axis, that line of reflection, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places in the negative direction. So to reflect this, I'm going to go 10 places in the positive direction. So above that line of reflection. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this would be T. All right, and then I'll get rid of this for us. We've got 2 more points to reflect this entire shape. So then I'm going to go with you here from that line of reflection. I'm 1, 2 places down below that line of reflection. So I'm going to go 2 places above that line of reflection to reflect you. And then my last point here is going to be point V, which is again 2 places down. So I'm going to go 2 places above, which is going to be at here. And now that I have these points reflected, I can create my shape, connect these points together, and I will see an image of the pre-image that is the same size, the same shape. The orientation might be different, but it is still going to hold those same, the same length and the sides, the same angle measures if we really got into those parts of this shape. The only difference you could really see is that, you know, S and T were on the bottom of this rectangle, and now it appears that they are on the top. So this is where you can tell that it does change that orientation of the way the shape looks.